Hello everyone, thank you very much for watching this video. I'm Mr. Matt and this is Dr. Todd. Dr. Todd, you want a cookie? Start class. There you go. Welcome to SAT, ACT Prep. This is quick drill set A to the LCM GCF. That's the least common multiple and greatest common factor video. So we're going to go through a brief introduction. If you haven't watched the guided lecture, independent practice videos, or the live streams, I would highly recommend those videos. I'm going to go through a lot more of this material in more detail at a more introductory level. We're going to kind of dive right into some advanced SAT examples. We're going to do this in two clusters, so you get 3 examples or 3 alternate problems for each type. Let me share my screen with you and we'll get right into it. If you have any questions at any point, just let me know in the comment section below. Just a brief review. So to find the least common multiple, remember that the least common multiple, you want to focus on the noun there. Actually, let me get another color. Shows up better. Focus on the noun multiple and the noun factor, because the name can be a little bit misleading. The word least can make you think that the result or the LCM should be smaller than the set of values. You need to concentrate on the noun multiple. A multiple is larger than a set of values. A factor is smaller than the set of values, and that's going to come in helpful. That's going to be helpful when we try and memorize the process of calculating each of these terms. So to calculate the LCM, we first want to break each of the values into prime factors. And then we're going to take each factor the most number of times it occurs in any one factorization. For the GCF, it's almost the same process. We first break each value into their prime components, but then we're going to take each factor the least number of times it occurs in each factorization. You end up multiplying, you take the product of all of those values. So for the LCM, you take each factor the most number of times and multiply them all together, all the factors together. For the GCF, you take each factor the least number of times it occurs in any one factorization. Not overall, but how many times, the least number of times or the most number of times it occurs in any one of the factorizations. So each of the values that you factorized. The document for this lesson is number 1002-7, so that's available at Certified Learning Center's website. The link for that will be in the description below. The Word and the PDF documents are both available. Let's look at question number 1. So Susan lives in Houston and visits her parents every 12 days. Her brothers Daniel and Samuel both live in Los Angeles. Daniel visits their parents every 25 days and Samuel visits their parents every 15 days. If they all are together on New Year's Day, how many times over the next year will all the family members be together at their parents' house? So please pause the video and take a few moments and solve this problem, and then unpause the video to watch the solution. So if we think about these rates of visitation, right now they're in terms of the individual people, Susan, Daniel, and Samuel. So right now they're individual rates of visitation. If we find the LCM of these 3 different rates, we'll have the rate of simultaneous visitation, or in other words, the rate at which they are all visiting at the same time. So let's go ahead and factorize each of these terms, each of these rates. Susan visits every 12 days, Daniel visits every 25 days, and Samuel visits every 15 days. So 2 numbers that multiply together to get 12 are 3 and 4. 3 is prime, so I'm going to circle it and I stop because I can't break it down any further. 4, however, breaks down into 2 times 2. 2 is prime, so I can circle those 2 factors and stop there. 25 breaks down into 5 times 5. 5 is prime. 15 breaks that into 3 times 5. Both 3 and 5 are prime. So to calculate the LCM, I'm going to take each factor the most number of times it occurs in any one factorization. So with 12, let's start with the factor 2. 2 occurs 2 times in 12, 0 times in 25, 0 times in 15. So I'm going to take 2 2's because 2 is the most number of times 2 is used in any one factorization. Moving on to 3. 3 is used 1 time in 12, 0 times in 25, 1 time in 15. So 1 time is the most number of times 3 is used in any one factorization. So I'm going to take 1 3. Then moving on to 5. 5 occurs 0 times in 12, 2 times in 25, and 1 time in 15. So 2 is the most number of times 5 occurs in any one factorization. So I'm going to take 2 5's. If I take the product of all of these values, 2 times 2 times 3 times 5 times 5, that's going to give me 300. So that means that every 300 days, and only every 300 days, will all family members be together at their parents' house. So over the next year, there are 365 days in a year. So if we take 365 days and divide it by 300, that's going to give us a decimal answer of 1.2. But the 0.2 doesn't represent another visitation. It's 20% into the time it takes for another whole visitation by all family members. So here the answer would be 1, answer selection B. Question number 2 asks, Donnell lives in Miami and visits his parents every 24 days in Palm Beach. His sisters, Veronica and Chanel, both live in New York City. Veronica visits their parents every 36 days, and Chanel visits their parents every 42 days. If they are all together on New Year's Day, how many more times over the next 5 years will all the family members be together at their parents' house? So pause the video and take a few moments to solve this problem. So again, if we find the LCM of these individual rates of visitation, we'll found the rate of simultaneous visitation, or the rate at which all family members are together at their parents' house. So we're going to factorize the individual rates of 24, 36, and 42. So 24 breaks down into 3 times 8. 3 is prime, but 8 breaks down into 2 times 4, and 4 breaks down into 2 times 2. 36 breaks down into 6 times 6, each of which break down into 2 times 3, and both of those factors are prime. 42 breaks down into 6 times 7. 7 is prime, but 6 breaks down into 2 times 3. And so solving for the LCM, we're going to take each factor the most number of times it occurs in any one factorization. So starting with the smallest factor of 2, 2 occurs 3 times in 24, 2 times in 36, and 1 time in 42. So 3 is the most number of times that 2 is used, so I'm going to take 3 2's. 3 is used, the next factor, 3 is used 1 time in 24, 2 times in 36, 1 time in 42. So 2 is the most number of times 3 is used, so I'm going to take 2 3's. And now the only other factor is 7. 7 is used 0 times in 24, 0 times in 36, 1 time in 42, so I'm going to take 1 7. Taking the product of all of these values, I'm going to get 504. So every 504 days, and only every 504 days, do all of these family members visit at the same time. And so if we're trying to find out over the next 5 years, so if we're talking about 5 years, I can write that as a given value because I'm going to convert it using fractions. I'm going to write that as a given value as a fraction by just putting it over 1. And I'm going to multiply that 5 years times 365 days over 1 year. Because notice that 365 days is 1 year, so conceptually this is something divided by itself. 365 days divided by 1 year is something divided by itself. Something divided by itself is always 1, or is equal to 1. 1 times anything is that same something. So you're not changing the value here, you're just manipulating the units. Because when you do multiply across, now the units years in the numerator and the units of years in the denominator, getting tongue-tied here, will eliminate, leaving your answer in terms of days. So we're going to have 5 times 365 days, which is going to be 1,825 days in 5 years. If you divide that by a rate of 504, we're going to get 3.6, or thereabouts, rounded. 3.6 rounded, but the 0.6, that's it's really 3.621 if I were to round to the thousands there. That represents 62.1% into the next 504 days it takes for them all to visit together. So the number of times that they actually all see each other over the next 5 years would be 3. Answer selection D. Question number 3 asks, Robert lives in Atlanta and visits his parents every 12 days. His brothers, Juan and Davis, both live in Seattle. Juan visits their parents every 9 days, and Davis visits their parents every 27 days. If they are all together on New Year's Day, how many times over the next 3 years will all the family members be together at their parents' house? So pause the video, please, and take a few moments to solve that problem. So taking these individual rates and factorizing in order to solve for the LCM, we're going to take 12, 9, and 27. 12 breaks that into 3 times 4, and the 4 breaks that into 2 times 2. 9 breaks that into 3 times 3. 27 breaks that into 3 times 9, and 9 breaks that into 3 times 3. If we calculate the LCM now, taking the smallest factor, starting with 2, 2 occurs 2 times in 12, 0 times in 9, 0 times in 27, so I'm going to take 2 2's. 3 occurs 1 time in 12, 2 times in 9, and 3 times in 27, so I'm going to take 3 3's. Multiplying these guys all together, I'm going to get an LCM of 108. So if I'm talking about 3 years, how many times over the next 3 years do they all meet? I can first convert 3 years into days by multiplying 3 years by 365 days over 1 year. That's going to cancel years with years and leave me with 1,095 days. So if I have 1,095 days in 3 years and I divide that by the rate of simultaneous visitation, which is 108 days, so they visit each other all on the same day every 108 days, then I'm going to get 10.14. So 10.14 rounded, which means that they actually see each other a total number of times of 10 times over the next 3 years. And that's answer selection B. Question number 4 asks, a teacher is making back-to-school packages for students. If he has 156 paper clips, 78 pencils, and 39 erasers, what is the greatest number of identical packages that he can make? So please pause the video and take a few moments to solve this problem. So now, instead of taking values and expanding them forward, we're taking these values and protracting them back because we have to take these total sums and divide them into equal groups. So now we're looking really at finding the GCF, the greatest number that can be divided, that each of these numbers or values of items can be divided by. That would represent the greatest number of identical packages that could be made. So we're going to take 156, 78, and 39 and factorize them. So 156 can break down into 12 times 13. 13 is prime, but 12 breaks down into 3 times 4. And 4 breaks down into 2 times 2. "78 breaks down into 6 times 13, and 6 breaks down into 2 times 3. And 39 will break down into 3 times 13, both of which are prime. So solving for the LCM here, we're going to take each factor, the most number of times that occurs in any one, we're solving for the GCF here, not the LCM. So we're going to take each factor, the least number of times it occurs in any one factorization. So looking at 2 occurs twice in 156, 1 time in 78, 0 times in 39. So this can be a little bit tricky. 0 is the least number of times that 2 is used. So you're going to take 0 2's. Therefore, we're not going to take any 2's. So if a factor doesn't occur in one of the factorizations, then you don't include it in the calculation for the GCF. Moving on to 3 occurs 1 time in 156, 1 time in 78, 1 time in 39. So we're going to take 1, 3. 3 is the least number of times, 1 is the least number of times 3 is used in any one of the factorizations. Moving on to then just 13. 13 is used once in 156, once in 78, once in 39. So we're going to take 113. 3 times 13 is 39. Now they're asking, what is the greatest number of identical packages that he can make? So 39, the GCF, would be equal to the greatest number of packages, identical packages, that he could make, which would be answer selection D. In the next questions, we're going to ask more specific, in the next problems, we're going to ask more specific questions relating to the individual components of paper clips, pencils, and erasers. So notice that the GCF of 39 means that you could divide each of these values by that GCF, and you would find the individual number of items in each of the in each of the identical packages. So 156, for example, divided by 39 is 4. So there would be 4 paper clips. 78 divided by 39 is 2. There would be 2 pencils, and 39 divided by 39 is 1. So there would be 4 paper clips, 2 pencils, and 1 eraser in each of the identical packages that the teacher would make or could make. Question number 5 asks, a teacher is making identical back-to-school packages for students. If she has 2,700 paper clips, 150 pencils, and 90 erasers, how many pencils will each container have if she makes the maximum number of identical packages possible? So please take a few moments and attempt this problem. So again, we're talking about taking individual numbers of items and splitting them into equal groups, or equal groups containing equal number of items. So we need to calculate the GCF here. Let's take 2,700, 150, and 90 and break them into their prime components. Any number that ends in 0 is going to be a multiple of 10. Any number that ends in 2 zeros is going to be a multiple of 100. So 2,700 will break down into 27 times 100. 27 will break down into 3 times 9. 9 breaks down into 3 times 3. 100 breaks down into 10 times 10. And 10 breaks down into 2 times 5 each. $150 will break down into 15 times 10, 15 breaks down into 3 times 5, and 10 will break down into 2 times 5. 90 will break down into 9 times 10, 9 breaks into 3 times 3, and 10 breaks down into 2 times 5. So calculating the GCF here, we're going to take each factor the least number of times it occurs in any one factorization. So starting with 2, 2 occurs 2 times in 2,700, 2 occurs 1 time in 150, and 1 time in 90. So we're going to take 1, 2. Looking at the factor 3, 3 occurs 3 times in 2,700, 1 time in 150, 2 times in 90, so we're going to take 1, 3. Looking at 5, 5 occurs twice in 2,700, twice in 150, and 1 time in 90, so we're going to take 1, 5. Two times 3 times 5 is 6 times 5, which is 30. So if we take the number of pencils, if we're asked for the number of pencils that each container will have, then the number of pencils is 150. If we have 150 total pencils and we make 30 identical packages, then that's going to be 5 pencils in each package. And that's answer selection A. Question number 6 asks, a teacher is making back-to-school packages for students. If he has 5,400 paper clips, 3,240 pencils, and 720 erasers, what is the ratio of the number of erasers to the number of paper clips in each identical package? Please pause the video and take a few moments to solve this problem. So again, we're taking values and splitting them into equal groups. So we want to find the GCF of all of these individual values, individual amounts of items. So we have 5,400, we have 3,240, and we have 720. So 5,400 will break down into 54 times 100. 54 will break down into 9 times 6. 9 breaks down into 3 times 3. and 6 breaks down into 2 times 3. 100 will break down into 10 times 10, each of which breaks down into 2 times 5. $3,240 ends in a 0, so I know it's divisible by 10. So that's going to be 324 times 10, and 10 breaks down into 2 times 5. 324 looks like it's divisible by 9, which it is. That breaks down into 9 times 36. 9 breaks down into 3 times 3. 36 breaks down into 6 times 6, each of which break down into 2 times 3. And then lastly, we have 720, which will break down into 72 times 10. 10 breaks down into 2 times 5. 72 is 8 times 9. 9 is 3 times 3. 8 is 2 times 4. And 4 is 2 times 2. So if we solve for the GCF here, we're going to take each factor, the least number of times it occurs in any one factorization. So starting with 2, 2 occurs 3 times in 5400. 2 occurs 3 times in 3240. Excuse me, 2. 2 occurs 3 times in 5400. 2 occurs 3 times in 3240. And 2 occurs 3 times in 720. So we're going to take 3 2's. Oh, excuse me, 2 occurred 4 times in 720, but we're taking the least number of times, so we're still going to just take 3 2's. Now let's move on to 3. 3 occurs 3 times in 5400. 3 occurs 4 times in 3240. But 3 occurs 2 times in 7200. So we're going to take 2 3's. Now looking at 5. 5 occurs 1 time in 5400. 5 occurs 1 time in 3240. And 5 occurs 1 time in 720. So we're going to take 1 5. That's all of the factors. So if we take the product of all of these values, then we're going to get 360. So we're going to be able to make a total number of 360 identical packages. So if we ultimately want the ratio of the number of erasers to the number of paper clips, the number of erasers in each package is going to be the total number of erasers, which was 720, divided by the number of packages that we're making, which is 360. And that's equal to 2. So there's going to be 2 erasers in each identical package. The number of paper clips is going to be equal to the total number of paper clips that we started with, 5400, divided by the number of packages, of identical packages that we're able to make. 5400 divided by 360 is 15. So the ratio of the number of erasers to the number of paper clips is going to be equal to 2 to 15. And that's answer selection C. Let me move my screen up so you can see all of that. If you have any questions, please feel free to drop a comment below, or I'm also always available on my social media. Those are all linked in the description. Otherwise, Thank you very much for watching. If you find these videos helpful, please subscribe, like, and share with your friends. And Dr. Tot, do you want to say goodbye to everybody? Dr. Tot, do you want to say goodbye? Hey, do you want to say goodbye to everybody? You want a cookie? Come on, you want a cookie? Dr. Tot doesn't want to say goodbye today. But thank you very much for watching. Have a great rest of your night, and I'll talk to you all soon.